Okay, good evening. Welcome to second episode of Tech Thinkers, and I hope you all are enjoying your evening tea. And we will try today to make your tea more sweeter. You will really enjoy in this cozy winter evening our discussion. And my guest today is Sachin Kalantri, who is known to everyone in the tech world. But personally, also, I think I owe a lot to him because not just he was among first clients, but the way Sachin has kind of honed and mentored me, and I believe everyone who has worked with Sachin would agree that there has always been that partnering spirit rather than the typical client and maybe vendor relationship. I have seen how he has helped me and my colleagues and other members, how he has helped us through really developing our own products over a period of time. So that's something great about Sachin. Sachin has more than 30 years of experience, worked with organizations like Qualcomm, TCS in the past. And if I would say his specialty would be marketing technology, that's one of his specialities. He also holds some patents. We'll talk about that. Has also spent some time in US, and after that he came back to India and is here. Uh, I really welcome you, Sachin, and thanks for giving your time with on Tech Thinkers today.
Thank you, Faisal. Thanks for your kind words, and thanks for this invite. It's always a pleasure to be on the show with you, because you always try to do something novel and different for your audience, which I sometimes think is a great way of letting industry experience permeate through our communication chain, basically. So that's good.
Yeah, that's the whole idea behind Tech Thinkers, that all upcoming professionals as well as students, they get a hold of things and understand what's really happening inside the corporate world. Because there is, whatever we would say, there is a wall, there is a very a tall wall, a barrier kind of a thing for anyone to understand what's exactly happening. So while they may read through their books, through their courses about how things work, but eventually there is a wall. And I think these kind of sessions open up good gateways and opportunities for everyone to understand what exactly is happening inside.
Absolutely. And, I was in the US, and I've seen firsthand myself a lot of industry collaboration with universities, academia, etc., basically. Uh,
Mhm.
and as you said, there is a wall, at least in India. Luckily, the wall is slowly getting shorter and shorter. Somewhere down the line, I'm hoping that there will be a much deeper collaboration between industries and academia, to make sure that whatever is getting taught in the universities becomes relevant to the industry as students get out of their schools, essentially, right? That's one thing. Second thing is, I think if students learn something is practical, they can themselves create beautiful things, be entrepreneurs, etc., on their own, and do something worthwhile, essentially. So it's very useful to have that collaboration between the two. A lot of new
Yes.
research happens out of the academia that can also help industry, so it's a win-win situation for both. If you look at the patterns in US, even Europe for that matter, a lot of inventions comes out of academia, essentially universities.
Even like I think nothing great than example of Qualcomm, like that eventually happened, a collaboration between a professor and students.
Absolutely, I agree.
Yeah, yeah. So Sachin, I think it's great time to leverage, next 40 45 minutes or so, and really have some deep understanding around AI. There's a lot of discussion, and now we are seeing AI in action. First, I think Chat GPT was something which really took it to the levels where probably a lot many people understand and use it. Now, whatever way, we'll not talk about that. But and now recently we have also seen Gemini from Google, which again is something mind blowing. So really, when we talk about sky's the limit, sky's the limit. I think in AI we are now really seeing probably there is no limit. So I really wanted to understand from you, because chip plays a very, very critical role, in enabling technologies. In AI also, it has a greater role. So really wanted to start this conversation with you, understanding what exactly is the role of a chip in AI, and how is also probably chip architecture getting, a changeover because of AI.
Absolutely. No, it's a good question, Faisal. I would like to go back uh, in terms of the origins of AI, and maybe I can explain a little bit in terms of what AI itself is. First of all, as you said, AI is limitless because intelligence is limitless, right? There is no limit to intelligence, so how can there be a limit to artificial intelligence? There is no way. And this concept itself is not very new. This concept has been there right from the days of Alan Turing, who invented the first Turing computer, right? He is considered to be the father of AI. So almost, I would say 60, 70, 80 years. I don't even know the exact number of years, but definitely more than 50, 60 years. And my first brush with AI happened when I was in engineering. In my bachelor's, this was 88, 89, 1988, 89. I had taken a project on Devanagari character recognition. So
Oh,
those days, it was actually a very challenging project because you didn't have tools, you didn't have powerful computers, etc., etc. And when I approached my guide, uh, she herself was a PhD, Professor Joe, who had returned from either US or Canada, one of the two places. She had taught there, she had seen the industry. And when I said, ma'am, I want to do this, she actually encouraged me. But she said, you will need to find an expert who can guide you. So we went ahead, me and my partner, we went ahead and found an expert, Dr. Sampath. He actually introduced us to a lot of concepts of AI. So that time we didn't know AI. We just had a thing that let's do something which is character recognition. That itself was a big, big thing. So then when we went to him, he actually gave us a download of what AI actually means. So in his simple definition, AI was nothing but mimicking human thought process. That was a single line definition which is still in my mind, which he had told us. So he said, if you can program it in such a way that the computer starts mimicking your behavior, then you have achieved AI, right? Now when we were looking at characters those days for recognition, we had to think in terms of how our brain thinks, how to interpret a or b or k, right? Because it was intuitively coming to us. We had to
hmm.
consciously think in terms of how it was coming to us. So then we started saying, okay, now a means it has a curve like this, second curve like this, there is one vertical line, then one small horizontal line, etc., etc., basically. So we started recognizing patterns, essentially, right? Now if I had to recognize patterns, I have to first uh, be able to identify what all patterns are there in the image. In those days, it's interesting, there was there were handheld scanners. If you, I don't know if you've seen, just a
Yes,
roller kind
I
of
used
scanner.
it. I have
Just
used it.
you move it on the paper and it used to scan very slowly. You had to move it. You didn't
Yes,
have
yes,
desktop
yes.
scanners
I
like I
remember.
mean, lot of DTP companies, they used to have a bigger scanner where you could feed in a paper and scan it, and then using Adobe Photoshop beautify it, etc. But obviously in a school you have no luxury, so we bought a handheld scanner. We scanned it. When you scan it, a lot of noise appears. So these are some of the practical problems start coming in once you are getting into the technology domain. Basically, you remove the noise. Now after you have removed the noise, you have to segment the character, because you have a series of characters. How do you identify which where to segment? So segmentation comes into picture. After segmentation, you have age detection, those kind of things. Now the challenge is, we used to work with x86 based machines, no storage, 640 kilobytes floppy disk going in. You boot a computer, read from there, your program is also residing there. So there is no notion of any real time processing. The
Hmm.
biggest thing for us was, even if it happens sequential processing, at least we are able to go through the logic, basically.
Hmm.
From those days, where we have come today is a remarkable journey, basically. Because uh, when y- I described this process of character recognition in terms of how we were doing versus today, it is just like you are pointing your camera, and camera is already detecting everything, and even translating it into a different language, etc. So many things are already happening, right?
Hmm. Hmm.
Now, some of this is done programmatically, some of this is done using techniques which are more intelligent oriented, basically based on some of the data, etc., etc. Now, what is AI? When you look at AI, there are, or even before I say AI, if you look at any system, right? Any
Hmm.
system has an input, there is some processing, and then there is an output.
Yes.
For an AI system, input is nothing but lot of sensory input, data sets, historical past, surroundings. In many cases, it could be audio input, video input, image input. It could be location input, temperature input. Anything can be there, basically, right? And then you have some processing logic. That logic can be based on a algorithm, or it can be based on a combination of multiple things which are somehow uh, correlated, cross correlated in some fashion, basically. And
Hmm.
the world is very random, actually, right? Through this randomness, coming up with a accurate algorithm is always going to be a challenge. But
Absolutely.
you can always create a data set which is a superset of multiple instances of things that have happened or about to happen, etc., through the thought process that you have, and create a path which says, okay, if this is the input, this should be the output, right?
Hmm. Hmm.
This is exactly how our brain works. You
Okay.
see those couple of curves, straight line, vertical line, you say this is O. You see the shape of rho, you say this is rho, or sure, or whatever, right? Similarly, in images also, how do you detect where the boundary is between, say, a sea and the shore,
Hmm. Hmm.
right? All this is done uh, in our brain automatically, almost instantly, because you have billions of neurons working for you, right? And those neurons have, number one, a capability to recall things. Number two, it has capability to relate things, and it has capability to feed into the brain almost in parallel, lot of data, basically. And then the processor brain has the power to process it immediately, right?
Right.
So
Right.
what it means is, you have three things which are at your disposal all the time. One is huge amount of data, which is intelligence, essentially, right? This data
Hmm.
you have acquired and not learned initially yourself. That's why it is artificial intelligence. Second thing is, you are processing that data in real time, in parallel. The more you do in parallel, the faster the results are going to be, right? So there is
Right.
huge amount of processing required,
Hmm.
right? And then the third is obviously the output, in terms of how you present the data, create the outcome, etc., etc. But the first two things, which is actual data set and sifting through the data through some processing logic to create the output, which is the processing. These are the two most critical aspects of any AI, right?
Hmm. Hmm.
Large amount of data means you have to have large memory. Our brain has huge memory, very compact memory, very power efficient memory, right? Have you ever seen your brain go very hot? It doesn't. Now, sometimes you do say, "Oh,
Sometimes it.
master." Sometimes you do say, right? But that is exactly because you've been thinking a lot, basically, right? So
Yes, yes.
every at the end of the day, it's a physical thing, right?
Hmm.
You're
Hmm.
spending more energy, so it's getting hotter. So it's true for any processor. Brain is no exception there.
Right.
And then you have a lot of data which is actually memory, and then you have to have fast DMA, which is the direct memory access
Hmm.
between processor and the memory to make sure the data is flowing very quickly, essentially, right?
Hmm.
So
Hmm.
communication becomes very, very critical. Now, communication has multiple nuances. I'm terming communication in a very generic way. Communication can be even on the board itself. There is a communication happening between your physical memory and the processor, or
Right.
it within the processor itself, which is happening between different components of the processor, essentially, right?
Right.
Or
Right.
it could be communication between your processing engine and cloud. So
Absolutely.
connectivity in all senses are going to be extremely important here in this case.
Hmm.
Now, when we started with a lot of these newer algorithms which were able to assimilate a lot of data sets, etc., that became possible initially because of the advent of cloud. Because
Hmm.
once cloud came, lot of capacity in terms of processing as well as data became available,
Right.
right? There were huge data centers, powerful, extremely powerful servers, machines who could that could process data, create a lot of learning engines, etc. Basically, very effectively, very powerfully in the cloud.
Hmm.
And then you had applications sitting at the edge, which were working with the cloud to get the answers, etc., etc. Basically, that's how most of the integration happened. And that's a great beginning because it has actually transformed what I was doing those days into what can be done today, essentially, right?
Absolutely.
And
Yeah.
from here, it is setting a foundation to take it to the next level, which is essentially doing it at the edge is essentially where most of the fun is, in the sense that that's where the consumption of the intelligence happens, right?
Hmm.
So you
Hmm.
may be creating intelligent models, etc., in the cloud, but the consumption is still happening at the edge, because that's where a human is interacting or a machine is interacting, right? And there are many instances where you need to have those responses in real time.
Right.
Number one. Number two is there are many instances where you may not even have connectivity going back into the cloud. So you have
Hmm.
to rely on things being done locally, right? So
Absolutely.
if we
Yeah.
have to do things locally, and I'll give you some of the examples where it is critical, and there will be numerous of those examples where it will become critical. But the moment you say that it has to be done at the edge, it means you have to have enough processing, enough storage capacity at the edge, essentially,
Hmm.
right?
Hmm.
And that's what is driving the chipsets of today, the processors of today, how to create a structure whereby lot of that processing can be offloaded from the cloud
Hmm.
to the end device. Can the end device be as powerful as the cloud? Maybe not.
Maybe not.
Can it do 90% of the job? Probably yes. Let's get that done, right? And then keep refining the engine, retuning the engine, depending upon the cloud for the last 10% or whatever. But at least 90% is getting done here.
Hmm.
It is giving you a much lower latency, number one.
Hmm.
It is reducing the cost of computing in the cloud
Yes.
tremendously. Now, 90% of your queries are happening locally, so 90% of the cloud dependence is gone, essentially. Cloud is still a good a place to create the learning models, etc., etc. Right? But once
mm,
the model is done, deploy it on the edge, and edge has enough processing capacity, enough memory to make sure that you can run through that model.
right.
Now, I'll give you an example. We have seen lot of transformation, and this is I'm giving you a very visible example of what is happening around us, right? There is huge transformation happening in the automotive industry,
Mm,
and this is essentially going from, say, a traditional electromechanical vehicle to a pure electronics automatic autonomous vehicle. Basically, it's
mm.
going to be a journey, right? To get to full autonomy, must nature is going to be a journey.
Yes, yes,
Lot
yes.
of artificial intelligence will be involved in this, right? So the car has to mimic whatever a driver has been doing all along while driving, especially in a country like India where driving is extremely chaotic. It's going to be a good use case for AI. One of the best use cases, if not the best, basically, uh, in India. So now the car, just look at us. When we are driving, we don't go by one rule because no one follows rules here in India, right? It's not rule based, so you cannot do a programmatic or algorithmic driving thing. You have to assimilate input all the time, right?
Mm,
And the
mm,
input is coming as audio, as video, as some visual, etc. Basically, right? So you have to have different types of sensors, which can be camera sensors, which can be radars, which can be lidars, etc. Basically, all that sensory input is coming into the picture. Of course, you
mm.
have, etc. You have map data, you have your own sense of location, you may have other things, but assimilating all this, you will be deciding at the vehicle itself what should be the next step for me as a driver. Me as a driver meaning for car as a driver.
Car as
The
a
car
driver.
is acting as a driver, basically, right? You cannot in this case depend upon network, mainly because in many cases you will not even have access to network,
Mm,
right? So you have to run those models locally on the vehicle. So that journey is going to be very interesting over the next few years,
mm,
or even so. When we say digital transformation of the industry, when digital transformation of the automotive, the journey of the automotive has started. It started actually a decade ago, right? Slowly it has started transforming. Now we see the acceleration of that transformation. Almost everyone realizes the benefits of doing it. Almost everyone is moving from, say, traditional IC engines to electric motors, etc., etc., right? So additional electronics is anyway coming into the car. There is going
mm,
to be a bigger battery, etc., anyway, for processing. Now the processors are also getting to that level where they can deliver this kind of performance to be able to run AI models in real time, essentially,
mm,
right?
mm,
So that's what the whole journey is. Uh, Over the last 4 5 years, if you look at the industry, they have continued to improve upon both the power and the performance of this, right?
right, right.
Maybe power is not that critical for a vehicle. It is still critical. That not critical as it is critical for a smartphone, for example, right? Because it's not continuously plugged. But at least the performance is going to be extremely critical. And
Mm,
there, whatever is happening with the new processors, with new hybrid architectures to run loads, appropriate loads on appropriate parts of the processor is going to be very critical, right?
mm,
And many processors, they have a combination of GPUs, CPUs, they have ISPs for processing visual inputs. They
visual.
have
Yeah.
sensory processors essentially to analyze those. And of course, now also coming into picture dedicated AI engines, basically,
Mm,
right?
mm,
Why
mm,
AI engine is required? Because typically when you look at a processor, it's more of a scalar processing. It is doing computations in one dimension essentially, right? But
Right.
when you look at AI can be very complex. You can have multiple dimensions, two dimensions,
Hmm.
three dimensions, four dimensions, five dimensions, which can be done programmatically. I mean, our human mind can visualize only three dimensions probably, but a computer has no limit. It can visualize four, five, six dimensions, and that's where the concept of tensors comes into the picture. So you have to have tensor processing capabilities essentially within the processor, and that's where dedicated AI engines, which are capable of doing vector processing and tensor processing, comes into the picture. Those are evolving. The latest we have seen, one of the chipsets is already talking about 10 to 15 billion AI parameters capable, right? Uh, Over the next couple of years, I'm sure it will be closer to 70, 80, even 100 billion parameters. I don't think that those days are far away. When that happens, truly, I think a lot of that processing that we've been talking about, which is required for, say, level 4, level 5 autonomy in vehicles, will come into the picture. So, coming
Hmm.
back, I think uh, for any AI system to be able to respond appropriately with a proper output, it has to have a good sensory mechanism, which is the input and the data sets, and then it should have a good uh, what you call processing to correlate that data set to the learning model that they have, right? And based on that, take actions essentially. So that is going to happen now. Going back to what I was talking about for my bachelor's project, I'm just jumping a little bit.
No, no,
Uh,
please.
in that, what happened was, and this is just to give you an example in terms of in those, I'm also getting a little nostalgic right now with those. So uh, we spoke to Professor Sampath, and he said, let's do this using a mechanism called pattern matching, basically, right?
Okay.
So you do segmentation, you age analysis, segmentation, and then use pattern matching. I said, fair enough. So feature extraction and pattern matching, those were the two techniques. So we did that, and obviously, just to save the time during the Viva Voce, we were asked to keep the images scanned so that we don't have to go through the scanning and all that, right? Because typically when you have 100 students, uh, invigilator doesn't have so much time, so we kept the images scanned. And when I was asked to show the demo, I input the image using the floppy input, basically, right? It's for a scanned image, and the file name was r dot img, right? Just to be able to recognize that this is R. Then when I input the image file r.img and the output came as R on the screen, Invigilator was very impressed. And then he said, how do you know? How do I know that you have done it programmatically and not just on the basis of image name? You are saying, oh, this is R image. So just reading the file name.
Okay.
So that was a very pertinent question that time because people could do it. So I said, okay, let's change the name of the file. Still, it should show R because the image data in the file is for R. So we
Hmm.
did that. I proved it to him, and then he was very happy. So
Okay.
I just want to complete that part. Anyway, I think so. Uh, so one thing is how the things are moving in terms of building blocks. Now, to be able to deliver on those building blocks, luckily, process technology is also improving.
Right.
Right? Without the right process technology, you will not be able to achieve the performance,
Hmm.
basically, because there is a limit in terms of how much. I mean, you can make CPUs bigger, You can put a lot of parallelism. Of course, power consumption increases there. Size also increases. But how do you make sure that while keeping the form factor smaller, reducing the power consumption, uh, you can deliver more performance, more output? And that's where the process technology comes into the picture. We are already here at 3 nanometers and looking towards 2 nanometers, and I think we'll do pretty good in the next 2 3 years at least, and then see where it goes. But I don't think 50 plus billion parameters is unthinkable today.
That's
Yeah, that's where it
that's
is.
incredible. Like, I think the entire first of all smartphones, and then a lot of these smart devices, they sped up all these transformations and changes so rapidly. I
Absolutely.
don't recall, like, I think before smartphones it was mostly 145 nanometer, or maybe I don't recall even 90 was there, or maybe 90 was there. But
180, 190, yeah,
yeah,
90 was there. 60 and 90 also came
this
slightly.
was like, it was very advanced.
Yeah, yeah,
But now look at like what has happened. We're not talking 3 2, and I am sure very soon we'll be talking one, and then I don't know what will happen.
absolutely.
That's phenomenal. And these numbers like 50 billion, and like these are not
Many times,
something.
I think it's a vicious circle in the sense that innovation builds on top of innovation, basically, right? The
Hmm,
reason this has happened, Faisal, if you really look at the history, right? PCs had a head start, actually,
hmm,
right? They could have gone from strength to strength, but the challenge with PCs was it could not scale in numbers the way smartphones have scaled.
yes.
As they started scaling, more and more people started building innovation around it,
Hmm,
right? So you see display innovation, camera innovation, you see peripheral innovation, you see battery innovation, you see form factor innovations, you see application related innovation. All this was possible because of fundamentally two or three things. One thing was the power of connectivity.
right,
Second thing
absolutely.
was the mobility. It has become, I mean, smartphones have become inseparable part of our life today, right? And once that happens, you get a scale. Once scale, once you get to a scale, then other things, they for example, the process industry, right? They also got interested in investing. If I don't have a scale, I'll think three times, or maybe
Hmm,
10 times, whether I can afford to put a 5 nanometer fab or not, right?
right.
Because you need scale. Now that there is the scale, TSMCs and Samsungs of the world, they are more and more encouraged to put at latest and greatest forward, basically invest billions of dollars into newer nodes and newer technologies, efficient technologies, better performing technologies. So it's building on top of this, and as the innovation has happened in smartphone, other industries are also leveraging that innovation. Basically, automotive is a great example for it, right. It's right there. Even automation, which is happening in the industry,
Hmm,
lot of leverage is coming from these technologies, which are actually created by smartphone industry, essentially.
yes, yes,
So
absolutely. So,
it's there.
yeah, I think that way it was really a game-changing device, or it still continues to be that kind of a thing.
Absolutely.
And that's why I love to always call it the jewel of electronics,
Until
smart.
we find the next jewel.
Yeah, so I don't know. There might be more diamonds and all those, but I think this will the jewel will
Never,
be smart.
never say no. Never say no. Some people are already talking about XR being the next thing.
So,
Uh,
so that's what I said. Like, yes, there will be diamonds, there will be more and more rubies and pearls around, but probably
Correct.
this recognition is difficult to be linked with any other device.
Correct.
Okay, So thank you. I think we understood very well the perspective of AI, and I think you explained it very well in a very simple form, and it will definitely help audiences to grasp it. And then how it what is the role of a processor, and what we are seeing, some of the fundamental changes that are happening in processor. Now there are always, see, before I come on to the next question, there are always, kind of these apprehensions. And you coming from the industry, someone who has been tracking this industry, I think always we have had this, okay, there will be heating issues, there will be, battery drain and all that. So what do you see? And I believe obviously somebody has spent billions of dollars, so those kind of things are very well taken care of. Having that said, but yes, when you go live there are issues, but then those also get kind of addressed in multiple iterations.
Poor
So
country.
what do you really see, you know in at the processor level? How is the battery management or power management different for processors which are more, I would say, AI first processors than the traditional legacy processor architectures?
I think traditional architectures have depended upon a very linear functioning, basically, right? Where all the workloads are either working on the processor, or you insert a separate card,
Hmm.
for example, right? A separate processor, co-processor you take, for example, for gaming or for AI, etc., etc. And that at times increases the cost of not just the silicon for the processor, but the overall cost, because now that processor requires its own memory, its own power supply, this, that, etc., etc., basically, right?
Hmm. Hmm.
Second thing is, it also doesn't help with compact form factors, essentially, because you are using multiple of those. So a lot of integration is happening within the same silicon now,
Hmm.
right?
Hmm.
Instead of going with disjointed pieces and integrating them externally, a lot of integration is happening within the silicon itself, basically, to make sure that, see, there are many advantages of that integration. Number one, obviously, the form factor and the size. Second thing is the latency of communication within the same. If you don't have to leave the chip, you can drive the communication between those to a completely different level, basically, right, at very low power, at low cost. uh, so that integration is happening. Third thing is, I think, even when you look at just the processor is not the sole thing in terms of driving the overall performance. There are multiple things which are involved. There is a processor, there's a driver, there are libraries, there is applications, right? Everything has to be optimized end to end to get the maximum out of the hardware, essentially, right? And to your point, when you say sometimes you see hitting issues and later on those get addressed, etc., because there could be issue in any of those things. Somewhere someone messed it up and it causes that issue, people fix it and it goes away. uh, but to be able to do justice to the overall performance of the processor, you have to make sure that everything is lined up properly, it's tuned properly, it's used in such a way uh, that you're not adding unnecessary layers in between, essentially, right? Staying as close to the hardware as possible, essentially, right? But at the same time, you have to stay modular so that you can build on top of each other. Otherwise, you cannot expect code to be written for everything from scratch, right?
Hmm.
It allow you scalability. So every component has to be architected in such a way that it is optimally doing the performance it is supposed to do and running as close to the platform as possible, right? So that's very important. So from that point of view, a lot of these libraries which are coming up are going to be important. Even now, the models that are being tuned in the cloud, they may be very big models. How do we quantize those, optimize those for smaller form factor processors so that those can be run on the edge? That is another activity which is going to be very, very critical. essentially, and it's happening. A lot of people are doing it actually. uh, we have models like stable diffusion and other image processing models which are today
Hmm.
running on a smartphone, right? Of course, they are at the premium tier smartphones, but history has shown us that over the period of time, all the premium features come down, and
Yes,
today, if you look at the entry tier phone, which is available in the hands of people, is much more powerful than the premium phone we used to have, say, maybe 5 6 years ago, right?
absolutely.
So,
Yeah.
so it's going to happen. So across the tiers, it will happen automatically. The key is to continue to drive that innovation at the top tier, get the ecosystem to rally behind it. And when I say ecosystem, app developers, those who are creating models, and the industry who is going to be using those, all of them together, to to make sure that they understand the end-to-end value chain and the benefits of the system. I can tell you, I was talking to one of the real estate developers, and he told me a very classic problem, which is, I have so many land records which are spread across India, right? It's very difficult for me to keep track in terms of what is where, etc., etc., etc. Is it possible to do something using AI? A fit case, basically, for AI.
Hmm.
Input the documents, you have everything at your fingertips, essentially, right? You can query the model, you can uh, you can fish out whatever data is required at your fingertips, because those are structured documents, pretty structured documents. um, and you cannot expect people to use those documents to create databases by using data entry, etc. It will be a wasteful time. A lot of data entry errors will occur, a lot of issues will happen, right? And we have seen in the land records that you see with government databases, hajar errors, basically, right? So all those can be eliminated very easily. So those things are happening. I think to be able to do it at the edge and make it available to common person should be the goal of this exercise, right?
Hmm.
That means we have to come up with innovative use cases which can run on your normal devices that you carry. Smartphones is one of them. Now, of course, laptops, PCs are also there, right? If we are able to run on the, and then I talked about the moving computer, which is the automobile of the future. I shouldn't even say future. It's happening today, right? All these will have AI. It will become all pervasive in my view. There.
Okay.
And
So
again, it is actually artificial intelligence. So we have to remember, whatever we are teaching it to do, it will do it.
it will do.
Is like garbage in, garbage out. If we are teaching it wrong things, it will do wrong things, basically.
I think this garbage in, garbage out needs to now change to intelligence in, intelligence out.
I know.
Prob-
So somewhere, I think that how do you make sure that garbage doesn't go in and only intelligence goes in? That's where some framework has to come up, basically. And
Absolutely.
right now we are struggling with that. Whether it is a regulatory framework or some other framework, we don't know. I don't want to hazard a guess also there, but something will straighten it up in my view. But on the whole, I think benefits of the technology far outweigh some of the pitfalls that we keep hearing, or we see people concerned about. I don't think I'm overtly worried. Any technology has a potential to be misused, but that doesn't mean we can stop innovation, basically, right? And
Yes.
start putting it to good use.
Absolutely. I think, we had a very in-depth discussion around AI and processors. Probably I may need to invite you sometime again to have, because I have some questions left, but let's keep them parked for today.
No problems
Because
there.
I want to come on to the other side also, which should be beneficial for the audiences. But before moving on to that, I want to understand more about you as a person. So, I have seen you talking technology. It's like really living, breathing everything around technology, talking around processors and devices and other regulatory and other issues. But beyond that, what is Sachin like? What does Sachin like to do, love to do? Any hobbies, any
No,
pastimes?
there are many things. I mean, see, I'm a very family person, so always be around the family, friends, obviously. And as I think you talked about me being a collaborator, and that's how I am within the family as well, as a collaborator. We do a lot of things together. Uh, I picked up a hobby during COVID times, which was cooking.
Oh, okay.
And now my range goes from lasagna to masala dosa, basically. So I
Oh,
can cook anything. I can do puran poli, which is Maharashtrian dish. I can do dal bati, which is Rajasthani dish, South Indian, you name it. So that is one of the hobbies I've picked up. But more, I mean, outside of that, I love to travel. And when we travel, we undertake a travel which is very non-conventional. Just go to one part of the country or one part of the world and explore everything there, basically, be history, geography, culture, cuisine, language, people, all things. So it becomes very relaxing. You a lot of times get new perspectives, likes and dislikes of people, how people behave, etc. It becomes very very relaxing. And earlier I was doing it like, of course, in a corporate, when you are in a corporate job, you don't get to travel, get to have too much of vacation. But during the Christmas time, I used to take a break, where I would go within India, and during summer I would go outside, basically. So
okay.
two destinations, lot of things to see in India if we see it properly, right? And a lot of things to do, explore, enjoy. There is no limit in terms of how much time you can spend, right? But when you go there, you have a limited time, because you, at the most, you're going to get 2 weeks of vacation. Let's be fair,
Hmm,
right?
hmm,
And
hmm.
again, you may have to be on calls
You have
many
to be
times
on
while
the.
you are there. But assume that you are there for a couple of weeks. Any amount of planning you do beforehand helps, actually. So as a family, we used to travel, and we would create a plan, essentially, in terms of what to do, where to do, what to do. So a lot of exploring, etc. And through that, a lot of learning happens as well. So half the geography, history, and culture learning happens through that research itself. And then once you go there, you experience it essentially yourself firsthand. So that's one of the passions I have. Other than that, obviously, love to hang around with friends, etc. Watching movies is a passion as well. Of
Oh,
course, don't get to see too many nowadays, but whenever I get a chance, OTT is now helping us, right? And I was telling someone, once we have XR devices available, maybe we'll be able to watch and get a cinematic experience sitting at home itself. I don't have to spend 2 hours going to the auditorium, basically, to the theater.
mhm.
Earlier, while I was studying, I used to watch a lot of plays. I was in Pune, so
Okay.
Pune has a lot of Marathi, Hindi, English plays. I used to watch those. After coming here, after education, I didn't get to do much, but wherever an opportunity presents, I still love to go. Yeah, basically.
That's interesting. Okay, so I never knew your cooking aspect. I
Yeah.
understand you travel and other, but cooking is a discovery.
So I'm a
Now,
foodie. I eat everything. Of course, I have stopped eating non-veg. That's a different story. But I used to eat everything, more or less. So
okay.
once you start loving food, you can start loving cooking, basically.
Hmm, hmm. So yes, sometimes I also enjoy to cook. That's and I feel it's at times very de-stressing also. I
Very
don't know.
distressing. Actually, it's a time for yourself, because
Yes,
you are thinking in the background, you are doing something with a very focused thing, right? And it's time for yourself.
yes, yes, absolutely. Now coming on to other aspect, which I definitely wanted to check with you, is the technology marketing. Okay,
Yeah,
uh, so and then maybe a bit more about the product marketing. So what are, how do you see technology marketing different than the marketing of maybe services, products in other areas, as well as uh, can you give us a glimpse of what does product marketing entail?
absolutely. So I think before I say product marketing or technology marketing, let's understand what marketing itself is, right? It's actually showing your products in uh, in the uh, in the best possible way,
Hmm.
right? Now there are a couple of things. What is the product and who is the audience? So audience could be a consumer, end consumer. It could be a business. It could be a government. It could be industry or enterprise. It can be anything, right?
Hmm.
So
Hmm.
based on who you are delivering that, who you are communicating, marketing is nothing but communicating essentially about your products. Your strategies are different, even for the same product. Second thing is, what is the product? Now product is a very broad term. Product can be technology itself, product can be a physical product itself, product can be ingredient product itself, or product can be a service,
Absolutely.
right? So there are so many variants of, and each of these, they require different techniques and different strategies. So many times, I mean, they in the marketing terminology they call it. Some people call they started with three P's, and I think they have expanded it to eight P's now. And those P's are essentially product, price, place, promotion, people, uh, positioning, performance, and processes. These are the eight P's essentially, right? So with it, these eight P's, you can apply them to anything, any product. And product as a
Hmm.
product, product as technology, product as a sorry, technology as a product, or a service as a product. All these things will come into the picture. But important is, depending upon what you are positioning, your strategies will change. Now let's look at technology marketing, where my product is, technology is my product. For example, I have a technology to create, say, uh, to efficiently generate electricity. I'm just making up an example, right, here right now. That is a product. If I'm trying to sell it to an end consumer, then I have to think from the end consumer point of view, what he will be looking for.
Right,
Then I have
right.
to look at who is my target audience within the end consumer. Is it the adults in the household? Are they the influencers, or is it the companies, enterprises who are selling electricity to consumers? Then it becomes a B2B product for me. Or if it is uh, the government, where government tries to say, no, no, this is efficient technology, we have to conserve electricity, let's start using this, just the way it happened for example, for the LED bulbs, right? So depending upon who the audience is, my marketing pitch will change, because then I have to look at what is the benefit I'm conveying of that product to the consumer. This is one
Right,
thing. Second thing is, whether I am actually creating a new product category, or I am trying to play in the same space which already exists, but trying to create a differentiation versus
hmm.
existing products. Strategies are completely different. When you are trying to create a product positioning, new product category, you have to do a lot of heavy lifting in terms of communicating what the product is,
Hmm.
right? So if I did not have anything like a bulb before the LED bulb came, for example, I would have to first explain to people what the bulb is,
Right.
what it do for them, etc., etc., and then talk about the LED bulb. But in a product where bulb is already understood and I am bringing a LED bulb, then I have to just talk about benefits of LED bulb over the rest of the crowd, essentially. So the strategies are different. But the whole
Right.
idea is to make sure that we are actually communicating the product benefits. And the product can be technology when you are trying to sell technology. If you are
Hmm.
selling a product, for example, if I am selling a smartphone, I'm going to talk about the features, the performance, the battery life, whatever is relevant to the consumer, essentially, from the camera experience, etc. From that point of view. Now, the for the same product, my pitch to the consumer versus to the OEM, for example, is going to be different, right? Because
Different.
what OEM is going to be looking at is essentially how easy it is for me to build. Can I leverage the same platform across multiple tiers? What kind of software effort is required, how much energy I have to cost, etc., etc. So I have to look at those aspects. Versus if I am selling it to a consumer, then consumer doesn't care about what is inside. He is looking at, okay, processor is good, my battery is good, camera is good, all those tick boxes I have to do, essentially. So when I was in that product marketing role at Qualcomm and I was trying to do processors to consumers mean something and processors to OEMs mean something else, basically, right? So
Absolutely.
you have to manage both these things, essentially, to make sure that both of them understand what that means. Yes,
Hmm.
and that's a product marketing role. A traditional marketing, when you look at, is a very broad term and it can encompass many things, essentially. It's a very vast term. Many times people call it a art. I call it art, science, economics, social, mathematics, literature, everything combined together. You have to do, I mean, when you are communicating something, if your English itself is not proper,
Hmm.
you can communicate, basically. So literature is also important. Whether you're going to go and communicate in their language, that's important, in the language that the user understands. So many
Hmm.
things. It's a very broad thing where everything is involved. Every piece of art, science, maths, you can combine there, essentially, to leverage it.
Even
But
at
it's
times
a
culture
field,
probably.
in the sense that as a career, a lot of things can be done in both product marketing, technical marketing, essentially.
Hmm. Okay. So probably one last question I have, and that would be, around the current scenario of, what all is happening in the devices world, as well as when we look at from the India point of view. I think one of the very exciting times, uh, not just from the consumer point of view, but from industry point of view. Many things are happening even now. Probably we are not just not talking about products. We are also not talking about chipsets. That's something really good to see shaping up. So how do you see this as someone who has really walked this journey and has been an important element, or part of this journey of this walk? How do you see this change, and what can we probably expect in coming times? That would be my last question to you.
So I take the example of a mango tree, right? You have to sow the seed, nurture it, nurture it, help it with whatever is required to grow,
Hmm.
and then wait for whatever number of years, basically, for it to come to the full bloom. This journey in the semiconductor that we have started in India is actually similar. The seeds have been sown,
Hmm.
right?
Hmm.
Manufacturing has started here. Luckily, we have a huge market here. in India. So it's not that we have to look outside. Of course, we can leverage outside market as well to grow beyond India, and that we should do. But once the seeds are sown, now we have to make sure we keep nurturing it by bringing everything around it into the fold, basically, right? Entire ecosystem, right from OSAT, packaging, etc., fabrication,
Hmm.
board designs, and then the product design. All these things have to come together to become a complete end-to-end this thing. And it is not just about chip. You can create a chip, but there are many other components around it which also need to come up in a time bound
Yes.
manner, so that by the time chipsets are available or chips are available, you have those components also. I mean, simple things as passives, inductors, battery things have started happening already, but still cells are not getting manufactured. So I think slowly we are inching there. Backward integration has started happening. We will get to the next level, slowly, to the point that we will have our own complete ecosystem here in India. And that is critical. Once you have that, then what happens is you don't have to depend upon external supply chain for components, etc. Raw material is a different story. Raw material problems, some way or the other, they may start showing up, so we have to solve that problem as well. But I think market, ecosystem, those problems are getting solved as we speak, and we are going up the value chain, which is also good, right? And I think the policies, etc., of the government, they are helping drive. It's a single-minded focus, basically, right, to make it happen,
Hmm.
right? And
Yes.
it's not that just the prime minister Saab is saying, everything down below, everyone is aligned with that thought, essentially. Industry is
Absolutely.
also, and that's what is going to be helpful for us. Next 1 decade, I think it's going to transform significantly. We will see a lot of ACZ kind of things, basically. They may not be called ACZs, but kind of things where you have clusters happening, basically, for manufacturing of different components, chipsets being one of them, essentially, right? And then the lot of focus needs to happen within academia to help students understand how to do designs, right? Hardware designs, small simple hardware designs, and then how they can build on top of it. A lot
Hmm.
of that, uh, I was also reading one of the things, there should be needs to be a lot of focus on vocational training around design, etc., basically. I mean,
Hmm.
a lot of first principles and design principles we teach in engineering colleges, but maybe vocational training can also be another area where you directly explain the building blocks and then go through the design, essentially, because that is very invaluable. I think we need strong OEMs in India, which we lack today.
Yes.
Once that happens, I think we can be a little more self-sufficient once that happens. Right now we have dependencies. Very
Absolutely, absolutely. I think what a way to kind of wrap up this conversation. What I could just take away from your conversation is we saw over this period now perhaps every box, if we talk of mobiles and now other gadgets also, we see a make in India, label or tag on them, and probably in a decade's time or maybe earlier, we should be seeing some make in India components on the PCB also. That would be really,
Absolutely.
that would
Absolutely.
be
Absolutely.
really a moment. I think we all would be wanting to
Yeah.
celebrate and rejoice, and things are moving in that direction. That's really interesting. And
It is.
second is probably we are now, if I look at mobile, probably we are now in the fourth era. Now, first era was just about connectivity. Second was probably rich connectivity, which came through internet. Then third, probably applications, and now fourth is maybe smartphones may remain the default medium of intelligence, and that would be again an exciting trend to see and live through. Thanks a
Yeah.
lot, Sachin, for your time, for your really
Thank you for
very
having me, Faisal. It's always a pleasure. I hope I did justice to whatever you're looking
no,
for your
absolutely.
audience.
These deep, pointed insights. I think that's what was very very important for this conversation, and I'm sure audience would benefit from it, leverage this, and it will not only help them in their professional pursuits, but probably it will also allow people to think and broaden their horizons, and that's what this tech thinkers we are trying to do.
Correct. Yeah, yeah. No, it's a good initiative you started. Thanks.
Thank you. Thanks a lot.
Thank
Have a
you.
good day. Thanks.
Yeah.